Okay, number 24. So given that A is parallel to B, B is perpendicular to C, and C is parallel to D, what must be the relationship between A and D? So if you have line A right here and line B right here, we're essentially going to draw them as if, so you can understand it easier, if rather than being, like slanted parallel lines, if they were complete vertical straight lines. So they are going up and down vertically, and those two are parallel. And then when C comes along, and it is a horizontal line in this case, and it is perpendicular to B, we know that a vertical line and a horizontal line, when they cross, they make a perpendicular. So since these two are essentially vertical straight lines, and then a horizontal line comes along that is perpendicular to one of them, then it also has to be perpendicular to the other. So you can think of it that way, or you can think of it like transitive property, where since these two are parallel and one of them is perpendicular to C, then that means that A and C also have to be perpendicular by like transitive property. So there's like two ways you can think of it. And then when D comes along, and D is parallel to C, so those two are parallel, then if you were to continue this line A right here, I just made it curved, but pretend, it is a complete vertical straight line, and this is horizontal, still, because it is not perpendicular, parallel to C. When you extend this line, no matter where it hits, it's still going to be perpendicular to A and C, because you have the straight line and then the vertical line, and you have a horizontal line. No matter where that horizontal line is on that vertical line, it's going to be perpendicular. So you can think of it that way, or you can think of it another transitive property way is, since A is perpendicular to C and C is parallel to D, by transitive property, A and D also have to be perpendicular. So the answer here is, the relationship is that A is perpendicular to D.